In this video, we're going to be discussing the properties of trigonometry. But first, we'll start with a definition of what is trigonometry. Trigonometry, therefore, is the study of triangle measurement. Metry meaning measure, and tri, the root of triangle. All right, let's start talking about the study of triangle measurement. We're going to be discussing three essential ratios, right? So remember, a ratio is a reduced fraction. We have the sine ratio, and we'll refer to it mostly as sine, 3 letters. The cosine ratio, we'll refer to that as COS, and the tangent ratio as TAN. So we'll say the word sine, cosine, and tangent, but we'll just write the 3-letter abbreviations. And so all they are ratios. Now the first ratio we're going to talk about is the sine ratio. So we're going to refer to the sine of A. And it's going to be the ratio of the leg opposite the angle, so opposite angle A, to the hypotenuse. So here's angle A. The side opposite angle A is lowercase a to the hypotenuse. So that's going to be A over C. And the sine for angle B is going to be the leg opposite angle B, side B, over the hypotenuse, which is going to be B over C. So that is our ratio. Okay, let's move on to the cosine. The cosine, say the cosine of A, refers to the leg adjacent, right? And this means next to, right? Or neighbors. The leg adjacent to the angle and the hypotenuse. So if we were to start with the cosine of A, the adjacent leg is right here, the leg it's next to, over C. So that's going to be B is to C. And the cosine of B, well, if I start with B, the leg adjacent to it is A over C. So that's A over C. Okay. And our last ratio is the tangent. That's going to be the ratio of the leg opposite over the leg adjacent to said angle. So if we're talking about the tangent of A, I have my angle A, and that's going to be the leg that's opposite on top over the adjacent. So that's going to be A over B. If I were to do angle B, that's going to be the leg opposite, which is B, over the leg adjacent, which is A. So as you'll notice, that the tangent for the two acute angles is basically the inverse of each other. Right? One is A over B, the other is B over A, because opposite and adjacent flip-flop. All right, let's put this into a little bit more action with some actual values that will help iron this out. As with any topic, it'll start out a little confusing and iron itself out as long as you don't give up. Keep doing the work. Before we start, we're going to start off with a little helping acronym, SOHCAHTOA. And what SOHCAHTOA stands for is the 3 ratios. S in SOHCAHTOA stands for sine, O stands for opposite, divided by hypotenuse. So, CA, the CAH, cosine stands for adjacent over hypotenuse, and TOA, tangent, stands for opposite over adjacent. So as I look at number 1, the first thing they want me to do is to decide what the ratio for sine of A. So I look at A, and again, my sine ratio is opposite over hypotenuse, which is 5 over 13. I look to see if I can reduce that. 13 is prime, so that's not reducible. Next, I move on to cosine of A. Cosine of A is going to be the leg that's adjacent over the hypotenuse, so that's going to be 12 over 13. And since 13 is still prime, there's no reducing to be done there. The tangent of A is going to be the opposite, right? So here I am at A, the opposite over adjacent. So that's going to be 5 over 12. And now 5 is prime, so there's no reduction to be done there. Now we're going to go down the list for angle C. So we begin with our sine function of C. I go opposite over hypotenuse for the sine. That's 12 over 13. Next, I go for the cosine. Again, cosine is adjacent over hypotenuse. So that's going to be the adjacent leg over the hypotenuse, which is 5 over 13. And lastly, the tangent of C. Keeping in mind, the tangent of C is going to be opposite over adjacent, which is 12 over 5. Now again, take a look. My tangent functions are the reciprocals of each other. And what's interesting to notice is that the cosine of one angle is the sine of the other, right? So the cosine of A is the same as the sine of C, and the sine of A is the same as the cosine of C. And why is that? Because what is opposite for angle C is adjacent to angle A and vice versa. And that's it. All you got to do is just remember SOHCAHTOA and move slowly and carefully. So here we are again. SOHCAHTOA. And I would write that sort of on the top of every page that I'm working at to remind myself how this works. And now we go right into it. Sine of W. So here's W. Sine is opposite over hypotenuse. And oh, on number 2, I'm missing the hypotenuse. How do I get that? Leg squared plus leg squared equals hypotenuse squared. And now continue the work and finish that out. Press pause and complete the value for h on your own. I get that the hypotenuse is 15. So opposite over hypotenuse is 12 over 15. These both are divisible by 3, which is going to land us at 4 over 5. Now remember, the cosine of one is the sine of the other, so I know that cosine of x is 4 over 5 as well. The cosine of W. The cosine of W is going to be the adjacent over hypotenuse. So it's going to be 9 over 15, both divisible by 3 again, which is going to yield us 3/5. And again, 3/5 is going to be the sine of x. And the tangent of W is going to be the opposite over adjacent. So it's going to be 12 over 9, again, both divisible by 3, so that's 4/3. So then the tangent of x is the reciprocal of the tangent of w, so that's going to be 3/4. And there you have it. So first, you're going to need to find the value of x right here. Keep in mind that that's a leg, so that's going to be leg squared plus leg squared equals hypotenuse squared. And just so you know, this works out to be very nice. Then go ahead and find the sine, cosine, and tangent of L. Work smart for the sine, cosine, tangent of M, and make sure that you reduce your ratios. Okay, so finish number 3 on your own. Press pause and complete that now. Now that we have the ratios for the basics figured out, now we can start to identify how to find the length of a side using only one side and one of the acute angles in a right triangle. So we've been given that this angle here is 28 degrees and the hypotenuse is the length of 19 units. Well, how do you find x? Well, I know this much. I know that this is the opposite side and this is the hypotenuse. So I'm going to write opposite and hypotenuse. And then across the top of my paper, remember I said on each paper I'm going to write SOHCAHTOA. And what I'm going to look for is opposite and hypotenuse. So I kind of just go through. Opposite and adjacent? No. Adjacent and hypotenuse? No. Opposite and hypotenuse? Yes. That is the sine. And so I can either use the calculator in degree mode, making sure I'm in degree mode, or I can use the trigonometric ratios that we'll provide for you in this video, and you can always go back and use. And we have this idea right here, and all these ratios are given to us. So 1 degree, sine, cosine, and tangent. And we can use these values to help us solve problems. And you'll see what I mean in a minute. First, I'm going to set up the ratio. I know that the sine of an angle the sine of an angle, and we'll call this theta, is equal to the opposite side divided by the hypotenuse. Okay, that's the ratio. Now the actual angle in question, we're talking about the sine of 28 degrees is equal to what? The opposite side, which is x, divided by the hypotenuse, which is 19. Now I can go to my calculator, and there's buttons that say sine, cosine, and tangent, and we'll talk more in class about what it means to be in degree mode. But if I go into my calculator and I just type in sine of 28 degrees, and I hit enter, what I'm going to get is a multi-decimal number. And in this table, it's always sine, cosine, and tangent. And so when I'm looking at 28 degrees here, I notice that my sine, as my calculator will tell me, is 0.4695. So instead of writing sine of 28, I write what the sine of 28 is. It's 0.4695. And that's going to be equal to x over 19. And now I have a proportion. Technically, this is over 1. We cross multiply, and we get x is equal to 19 times 0.4695. So x is going to be equal to, and what is 19 times 4695? That's going to give us approximately 8.9205, or x is approximately 8.9. Good enough. So this is 8.9. And that's how you do it. Notice we can't use the Pythagorean theorem here because we only know one of the three sides. So this is our next fail-safe method. All right, let's try this again. Now, if you don't have a calculator at home, so you can't use the sine, cosine, tangent button, again, I implore that you spend the $3, $4, $5 and get yourself a halfway decent scientific calculator for at home. But if you can't get one, then you can just go to this video and you can use this table of values. This will get you from 1 all the way to 65 on this page. And on this page, downward down to 45 degrees, and from the 65 down to 89 degrees. And again, this is sine, cosine, tangent in that order. Sine, cosine, tangent in that order. So we move on to solving more problems. For number 3, I'm given a 21 degree angle or measurement. I'm given a side length of 26, and I'm given the variable x. So what side is this 26 with respect to this acute angle? This is the hypotenuse. What side is this with respect to the 21 degree angle? This is the adjacent side. So I look for my connections in my SOHCAHTOA model. So adjacent and hypotenuse. Opposite and hypotenuse? Nope. Opposite and adjacent? Nope. Adjacent and hypotenuse? Yes. Cosine. Cosine of some angle, theta, is going to be equal to the adjacent side divided by the hypotenuse. That's my first setup. So that's the first thing you write, is this whole show in words. Next, we substitute in the cosine and then the actual angle in question, which is 21 degrees. So instead of this variable in degrees, I'm going to write 21 degrees is equal to the adjacent side, which is x, divided by the hypotenuse, which is 26. Now what? Put this over 1, cross multiply and solve. X equals the cosine of 21 degrees. What is the cosine of 21 degrees? 21 degrees from my table, cosine is 0.9336. So that's 0.9336 times 26, right? All I'm going to do now is just multiply that out. And 0.9336 times that is going to give me approximately 24.3. Go ahead and press pause and make sure you can do all this on your calculator. Make sure you agree that the cosine of 21 is 0.9336, and then multiply it times 26 and confirm that you got 24.3. Once you do, you can put that on the drawing over here and say we're in good shape. Again, you can use a calculator or you can use the table of values. Just a couple of more. So here we are. We have the angle in question is 33 degrees. This is the hypotenuse. This is the opposite side. So opposite over hypotenuse sounds like our sine, but again, we have SOHCAHTOA. And I see opposite and hypotenuse. Opposite and hypotenuse is our sine function. So the sine of some angle is equal to the opposite side divided by the hypotenuse. Okay, well the sine of 33 degrees is 0.5446. So first I'm going to say sine of 33 degrees is equal to the opposite side, which is 15, over the hypotenuse. I know that my sine of 33 is 0.5446, so I'm going to cross this out and insert 0.5446, because that's the decimal approximation of the sine of 33 degrees, and that's over 1. And now we're going to cross multiply these two, right? Just to neaten up that cross multiplication. So for this one, a little bit different. I'm going to get x times 0.5446 equals 15 times 1, which is just 15. Now I have to go one more step on this one and divide by 0.5446. And I get x is equal to whatever that decimal, 15 divided by that decimal is, which is approximately 27.5. So this is 27.5 approximately. And that makes sense. It's longer than 15, and it should be. Over on number 7, I got my angle of 72 degrees. This is my adjacent side because it's next to it. This is the opposite leg. The hypotenuse has nothing to do with this question. So I have adjacent and I have opposite. So who's that? Adjacent and opposite sounds like tangent, right? And again, I get this from my SOHCAHTOA acronym. So my tangent of 72 degrees is equal to the opposite side over the adjacent side. And so the tangent of 72 degrees, we'll have to get that from the table of values. All right, and that's this last one here. It's always, again, sine, cosine, tangent. So tangent of 72 degrees is equal to 3.0777 is equal to the opposite side, which was 25, divided by the adjacent side, which is x. Put this over 1. Again, from our last unit, solving with proportions, it's going to be 3.0777x equals 25 times 1. Divide by 3.0777, which is just basic algebra 1. And I get x is equal to whatever 25 divided by 3.0007 is. I get approximately 8.1. So that's this side right here. This is 8.1. I think we're looking pretty good. What happens when we bump into some word problems? No problem. A ramp is used to load suitcases on an airplane. If the cargo door is 7 feet from the ground, so here's some ramp, right? And I don't know, so my crummy plane here, it's got wings like this, you know, and here's the windows of the plane. And this ramp is loading suitcases into that plane. And this vertical distance is 7 feet. So again, just to draw a nicer version of this, I have 7 feet high ramp. And the angle formed by the end of the ramp and the ground, right? So the end of the, one part of the end of the ramp is there, the other end is over here. But this is the one where the angle and the end of the ramp meets the ground. So this is 25 degrees. Okay, they want to know how long is the ramp. So this is the length of my ramp. So I'm going to just put an X right there. Now what do we have? We have the opposite side and the hypotenuse, right? So opposite and hypotenuse. In my SOHCAHTOA, right? SOHCAHTOA, opposite and hypotenuse is sine. So we have the sine of 25 degrees is equal to the opposite side, which is 7 feet, over the hypotenuse, which is the unknown, x. Put that over 1. We're going to cross multiply. From my chart, 25 degrees, again, sine, cosine, tangent. The sine of 25 degrees is 0.4226. So 0.4226 is equal to 7 over x. Put this over 1. Cross multiply. I'm going to get 7 equals 0.4226x. Divide by 0.4226 on both sides. And we're going to get x is approximately 16.6 feet. And that's it. Of all the various ideas and properties that we study throughout geometry, this is by far one of the most applicable things that you could learn, and maybe one of the more likely cases of somebody using this in real life. This is how we can measure lots of distances, especially if you want to try to measure distances across a river, things like that. In boating and in manufacturing, trigonometric ratios are all over the place. And these particular ratios actually pay to know them. And a variety of issues from welding to mechanical engineering. So I think this is some of the most exciting stuff we do. Anyway, that being said, you are to complete the rest of the problems that I didn't do in the first and second page, right? So you are to complete the rest of the problem in the notes portion of the handout. Feel free to use the calculator to identify the trig ratios, right? So you can use sine, cosine, or tangent button on the calculator, making sure you're in degree mode. If you're not sure, come up and ask us, and we can point you in the right direction there. Or you can go back to the portion of the video that has the ratios from the chart and get them there. All you really need is a basic calculator if you're going to use the chart to do the rest of the work. Of course, an inexpensive calculator, right? $5 calculator from Amazon or Staples is highly recommended. Right? Make an investment in your own education. And that's it. Hopefully this is helpful. Take care.